Good day, everyone, and thank you for joining us for today's webinar, Join the Digital Revolution, Improve the Way We Work in AEC. This is the first in our series of webinars for 2018, and we're discussing the ways we work in architecture, engineering, and construction, and how we can improve these processes. My name is Tracy Saunders, and I'm the Sales and Marketing Manager for Asite. With me today to present are Casey Rutland, who's the UK Director of Digital for Royal Haskell and DHV, and Rob Clifton, Asite's Digital Engineering Manager. We'll be handling questions and answers at the end of each presentation, but feel free to type any questions that you may have into the questions tab on your screen whilst the speakers are live, so that we can get to everyone's questions during each Q&A session. So we'll do one Q&A session after each presentation. Without further ado, I'll hand you over to Casey for the first presentation entitled Connected Digital. So screen share coming your way, Casey.
Okay, thanks very much, Tracy. Good welcome to this webinar, everybody. Thank you for the opportunity to Asite. I will start by explaining what's on the screen right now. Please don't take too much notice of it because I made it up. It's a completely fabricated formula, just to really make a point that all of these digital topics that I'm about to whiz through very, very quickly are interrelated, but are often talked about and spoken about and discussed in isolation to one another. So in terms of being digitally connected, what we're looking to do is to show how all of these relate to one another and what the opportunities are. So firstly, a little bit about me. It's a fairly accurate representation of me. This is me. I am an architect. As Tracy said, I'm the Director of Digital at Royal Haskell DHV, and also their leading professional for digital engineering globally. Additionally to that, I am engineer influenced. Spent 4 years working at Arup prior to my role at Royal Haskell. I'm an architect who wants facts and figures to determine how buildings work and operate. I love to use technology that's relevant to what it is I'm trying to do, that's going to make the business of what we do better. And I actually really enjoy the legal aspect of understanding my roles and responsibilities as part of a design team and the duties I perform with our clients. Other bits and pieces: diversity and equality champion, BREEAM assessor, author, lecturer, and blogger. If anyone's got any questions after this session, feel free to either go through Asite or follow my Twitter stream and ask me a question on there. I'm more than happy to respond to that. So if anyone out there has heard of VUCA, that's great. If you haven't, I'll explain a little bit about what that is. Harvard Business Magazine basically determined it as being this. it's crazy out there. And I think in terms of construction, in terms of technology and digital discussions, there is so much happening and so much going on that sometimes people feel overwhelmed by adopting that a particular digital process or understanding what's relevant for them as a company and how they can make the most of it. So this is really about giving you an understanding of all of the different topics and then finding your own route through that and how it's relevant to what it is you do on a daily basis. If you haven't heard of VUCA, this is what it is. It's basically to do with how much about how much you know about the situation and how well you can predict the results of your actions. And it basically stands for being volatile, uncertain, complex, and ambiguous. All of the things that basically terrify most business owners because they're things that they don't necessarily have a lot of control over. This terminology, VUCA, is actually used a lot in the military. They face a lot of the similar challenges in that the situations are volatile, uncertain, complex, and ambiguous. But this is a mechanism for dealing with those things. And we'll wrap up at the end with different tasks and different methodologies of how you might approach this VUCA environment and how it might help you make sense of it for your business. Additionally, I'd like to make this point. This is taken from an Autodesk publication, and it really hit home for me the change in the industry of where we currently are, and I think where we want to be and where we need to be in terms of what we do every day. And it's just really to say the age of guessing is over. And I think a lot of us, no matter what part we play in the construction industry, can look back over our careers or our current careers and say, actually, there's a few occasions or more than one occasion where you've guessed something. At best, educated guess maybe, but we are getting to a point now where we can use technology, software, processes, other people's experience digitally to actually prove using data, using science, using facts and figures that actually the decisions we're making are the right ones, or the ones we're making where we are not necessarily backed up with data can be emotional ones based on the data providing what it is we're trying to achieve. So what are we doing about it as an industry? Not necessarily talking about Royal Haskoning individually. As an industry, we are making great strides towards working in this way. So a lot of people on the call would be familiar with building information modeling, whether we call this better information management or building an information model. It is relevant to what we do on a daily basis. It's relevant to every part of the industry. Whether you're designers, contractors, cost consultants, clients, fabricators, parts manufacturers or product manufacturers, it's relevant to everybody. And it's about how we create information and build that information model throughout the life of the asset so that everyone can rely on that data. So more specifically, what we refer to in the UK is UK BIM Level 2. Which I've tried to succinctly wrap up into one sentence. It's the process of creating consistently structured, verified and reliable documents and data. I do like to switch the last two words around there, so data and documents, as data is becoming more important. The documentation generally is formed from that data. So that's what we end up with. And you'll start to see this picture build up as we go through this session. So really through the BIM process, we'll end up with structured data about our built environment. Now, we already have data, we have lots of information, but it's not very structured in a very good way. It's not shared very well. No one really aware of what they can do with that information, what they can use it for, what the purpose of that is. So the BIM Level 2 environment is to really succinctly wrap that into a package and say, right, this is the information the client needs, this is how you need to provide it in this format, and it makes it usable by everyone who's able to use it or likely to use it for their particular use. Now, jumping away from BIM related things to slightly related things in open data. And it's really the idea that once you've created something, make sure you've created it in a way that is compatible with other bits of software, or if you are truly opening up the data you've created and you have the right to do so, it's not owned by the client, then give it away, give it to people who may use it out there for another purpose, as long as you have defined the purposes it's used for. And that's really to do with using industry standards, using international standards. it's the way the internet works. It's based on HTML language. Everyone writes it the same. That's why it works wherever you go, whatever information you're trying to see. The good thing about data is that it's starting to have international language uses as well. So Building Smart International have the global data dictionary. So one particular property of an object can be translated through data terms into another particular language, and it will mean the same thing. It gets over the problem of us in different parts of the world using different terminology to describe things. So there's lots of mechanisms, lots of schemes out there that we can start to use to make sure everyone understands that this is actually what we're talking about and that we can use the data for its permitted purpose. So then we have structured data about our built environment, shared where appropriate using open data standards. The Internet of Things, I'm pretty sure almost everyone on the call has either got some sort of connected device or a device connected at home, connected to the internet, or it doesn't matter what it's doing, buttons to press to order things, or watches, health monitors, whatever they happen to be. It's basically the Internet of Things. It's a series of inter-networked physical devices embedded with technology that are sensors or actuators, as the text says. And what they really do is they either collect, exchange, or react to data. And if we're looking at things related to the built environments, it's to do with multiple different data sets. We'll come on to that in a minute. But it's all those sensors that are already built in to much of the products that we use. HVAC units often come with sensors about how they're operating. They're just not necessarily plugged into systems where they could be really valuable. So just one example of how internet-connected devices are enabling us to build bigger data sets that we can make informed decisions upon. So then we have this shared data and open standards supplemented by connected devices that are location aware. So not only are we receiving this information, we know where it's coming from and what it's applicable to. And obviously that leads us on to these vast data sets, and often confused with just size of data. The term big data, as it says on the screen, refers to the use of predictive analysis or behavior analytics to summarize lots of data and extract insight from it and give reason to that data for a particular purpose. Now, as we said, the scale of data is just one example of big data, or one part of big data, but it's summarized by IBM as the 4 V's. So you get volume, so the size of the files and the complex data sets that you're using, the variety, the different forms of data that we'll be using to make decisions, the velocity, the analysis of the streaming data, so that the speed, the rapid change of all this information where it's being updated or added to. And then we have the veracity. So how much can you rely on the data that's being created and what can you use it for? So there's a lot of, let's say, junk out there in terms of the data, particularly in social media, which is, big data is often associated with social media as being the populace of thought, and it's not necessarily that as a matter in all instances, because some people aren't on social media, so you're not necessarily representing the true demographic of a particular area using social media. So it's all sorts of things like that, like sensor data. Is it coming from the right place? Isn't it in the right location? So we've got to be aware of what data we're using and when we're using it. So you need to clean the data, use it in the environment it's supposed to be used in. So then we have all of this location-aware vast data sets changing quickly with varying accuracy, and this is where it starts to become quite uncertain. What is the data we're using? But we can use tools such as artificial intelligence and machine learning to run through that data quite quickly, much more quickly than we can as human beings, to then give us proper insights. So it will go out there and find the reason or a goal or an action or a result for whatever we ask it to do. The challenge we have in the construction industry right now is that we don't really have enough data sets for machine learning to learn from to give it any particular reasonable outcome. And I think things are being worked on in small pockets at the moment, but we are getting to the point where we can test certain things, but we kind of do have to use fake learning in some ways. And that doesn't relate in any way to fake news, but we are teaching machines in small environments with less influence from external influences, and we're controlling it in a way that doesn't really reflect reality. But nevertheless, we are starting to collect a lot of data for artificial intelligence to be able to go and scour, and machine learning to be able to learn from. Let's skip through that. So then we have software and tools that can analyze the data, spot relevant trends, perform tasks, and create predictions. And these are as useful during design, during construction or operation as any one of those stages, as well as in use through people using buildings and feeding back data back to design teams for the next design. So it really does have application, not in as scary a way as some people might think. Then we move on to blockchain, and again, one of the topics that's probably high on most people's agenda when it comes to digital, but not really understanding what it might be and how it might affect their particular work. Blockchain facilitates secure online transactions, simple as that. It enables that through disconnected data or dispersed data, and it allows things to be able to connect it, so one person can't change the network, change the chain without agreement from all other parts. So we don't know where it is, it's a distributed thing, and no one person can change it on their own. That creates the security, that creates the safe side of it, but we do need to make sure that these rules are created properly, and this will lead into not only cryptocurrency, which we'll get to in a minute, but smart contracts. So one particular way this can be used is through what we call IFTTT, and it's not necessarily what blockchain is, but it can be used in this way. And this is the way we might form smart contracts. And IFTTT means if this, then that. So you have an action, and if something happens to that, then this happens. So that could be something as simple as the client requires a deliverable. So if the architect delivers the information and it meets the requirements of the client, then they get paid. Something really, really simple. You have the trigger, if something happens, and then an action, then this will happen. And that can be a simple two blocks of a chain, or it can be a very, very complicated full construction smart contract, which will need a lot of working out, to be fair. But this is the type of technology that we're looking at, which will reduce long payment terms. It will increase transparency. It will allow people to be sure that what they're delivering meets the requirements and that they will be paid instantly. And that's really where we need to start going as an industry to catch up with others. So now we have all of that data flying around, being created about the built environment. We're operating in an environment where we have a smart contract, where it's secure, multiple parties are transacting with full transparency. And then again, often discussed alongside blockchain is cryptocurrency. Many people may have heard of Bitcoin and any other types of digital coins or coinage. But it's really a digital asset for paying for things, of exchange. It uses exactly the same technology as we said. It uses the blockchain technology to secure those transactions and to control the fluctuations in the value of that currency. It is said to be more stable than other currencies, but as we can see in the news, the value of Bitcoin seems to be going up and up and up. But it's also supposed to be less influenced by politics and commercial pressures, because it is controlled by the people who use it in the environment, and the influence doesn't sit with one person as such. So now we have our smart contracts with an online payment system that's not affected by politics or countries or regions or commercial pressures. It's just a much more open payment system. And then we have circular economy. So we're bringing in the environment elements of this now. So we're looking at reducing waste at every possible moment and making the most out of any products and materials that we use. The BIM level 2 process is about reducing waste and increasing efficiency. And the circular economy is really about that, but from a materials perspective, from a business perspective. One company's waste might be another company's product material. So we're looking at connecting those, and digital is really the thing that combines all those things and brings them together. So once we're creating information about facilities and about people using it and about the products that are in those facilities, we get to solutions such as carpet as a service. Rather than purchasing carpet, you hire or lease your carpet, which then goes back into a recycling model by the manufacturer. And that's really taking responsibility for the environment, but using the digital processes, using different business models to drive and help the adoption of circular economy thoughts. So now we've got that whole process running in a way that produces solutions that minimize waste and reuse resources. And then we go on to smart cities. And again, I don't necessarily like the term smart cities because it seems that unless you live in a city, you can't be smart. But there are plenty of schemes out in towns, villages, and hamlets that are clever. So we do prefer clever towns or clever villages. You can do lots of things. Using technology, using data sets created by public transport, by, as we said earlier, by social media, by council services. There's lots of data there, and you can offer better services at a reduced cost, enabling a better quality of life to local residents. Once we start to build those communities working more smartly or in a clever environment, that will inevitably lead towards smart cities. But what we're saying is that some people find smart cities a bit too far of a leap to jump straight to that, and actually clever towns is a much more tangible way for a local council to develop systems that work for them and make them understand what the benefits and opportunities are. So if we take all of those 9 topics and we place them in a circle, we can of course start at the BIM side of things and run all the way around, and they are in effect linear. But actually what you'll find is that any one of those can connect with anything. So BIM can directly feed data into artificial intelligence and machine learning. It can be paid for using Bitcoin or smart contracts, and it feeds very well into the circular economy and smart cities. So these all very much work together. But then you can also realize that all of the other topics relate to one another as well. So we can start to connect all these things together. So they are digitally connected. And I think the more we speak about the impacts and the opportunities of these different topics together as a construction or built environment industry, we will be making the most of these opportunities sooner rather than later. So as we said, BIM, open data, Internet of Things, big data, artificial intelligence and machine learning, blockchain, cryptocurrency, circular economy and smart cities, all very much digital topics on most people's digital agenda. And all have opportunities to make a real difference to anyone in the construction industry. I can't stress enough, despite the fact that we're talking about some fairly high level things, BIM is really the gateway. Without creating data about our built environment, none of the other things happen. We don't necessarily need to leap straight from level 0 to level 2. There is a lot to be gained from BIM level 1, doing that really well. Understanding how your documents are named and created and how they're shared properly and who can rely on what for what information. That is fundamental. That gets a lot of people on the way on their journeys. And it doesn't actually cost a lot to do that. That's just basically naming your documents properly and sharing them, ideally within a common data environment that your clients may be paying for. If they're not, pay for it yourself. It doesn't cost a huge sum of money, but they're cloud services. People can share information, track it, audit it, understand who was sent information, who accessed that information. It really does enable you to control the information that you were always creating before. But BIM level 1 is a very, very important step for a lot of people. Then finally, just summing up really, just on these 3 sides, if you don't have data, you can't automate it. If you have no data, you have no AI. And if you have no data, you have no smart cities. So it's really encouraging everyone to understand the part they play in this bigger picture, what the opportunities are, and how they can get on with things. So I'm available for questions now. In the meantime, I'll hand back to Tracy.
Thanks so much, Casey. We've just had one question come in so far. So what would your top 3 tips, probably on a very high level there, top 3 tips to start digital transformation in your own company, your own AEC organization, let's say?
Well, it's difficult to put it into a top 3 depending on what you do. But I'd actually go against the commonly discussed topics when we talk about BIM. It's all about collaboration, but really, if you're looking to implement BIM within your company, be selfish about it first. Understand it, understand how it affects your company in good ways, what the opportunities are, then look at how you might need to change the way you work. And I think lastly, as always, the technology and the solutions you aim for. Without understanding what the process is within your company, applying technology to a bad process will just get you that bad process, but faster and quicker. So I think that's the primary tip to anyone, really, and that's the coverall, is understand how you as a person, you as a company, use information, use data on a daily basis, work that out, draw a process that you repeatedly do over and over again, and then apply the technology or solutions to it afterwards.
Awesome. Thanks so much, Casey. We haven't had any other questions come through. If you do have any other questions for Casey, please just pop them through on the questions box and we will get to them later on this afternoon. Alternatively, you can email marketing@asite.com and we'll have Casey answer those questions that you have for him personally. Thanks for joining us today, Casey. I know you've got to rush. I'll be passing over to Rob for the next presentation.
Thanks very much.
Right, good afternoon, everybody. Let me just get this up and running. So, yeah, firstly, I mean, thanks to Casey there for that very interesting presentation, and always value his input in this topic, in which he is obviously one of the real kind of thinkers behind driving the industry. So, just to introduce myself, my name is Rob Clifton. I'm Digital Engineering Manager at Asite, and today I'm going to kind of be going through a few kind of concepts based around the digital revolution. So starting off then, digital transformation. It's a phrase that is kind of got a bit of a buzz around it at the moment, and I think it doesn't for me emphasize how important this phase within the industry is, and I think it doesn't have enough kind of power behind the idea that there is an impact on everybody here, and it's for that reason that I've kind of driven this phrase, the digital revolution, which again is kind of within the industry as well, but it's about the idea that we need involvement from lots of individuals across a huge amount of areas. So the digital revolution, what actually relates to this? I mean, Casey's covered quite a few of those topics there, so I'm just going to introduce or recap on some of those. So, you know, starting off at the bottom there, paperless environments. I'm a huge advocate for paperless. I quite proudly sit without a notepad or a pen at my desk, and badger most of the rest of my company about the values that can be had from paperless environments. You know, that is a basic starting point. We've got the Internet of Things, smart cities, which have kind of been covered. The idea of using new technologies and using innovation to our benefit across whatever kind of task we do, whether it's you know, work, personal, it doesn't matter. There's huge benefits to be had from new technologies. And then two specific topics related to our industry, being BIM and digital engineering. So BIM, it's a big buzzword, of course. It cropped up in Casey's presentation there, as it does most with the industry and anything related around this kind of area. Now, so what does it actually stand for? Well, I'm quite glad Casey also touched on this. Obviously, as a starting point, building information modeling, it is fundamentally what it does stand for. But there's quite a few of us within the industry that, to try and explain and elaborate around the importance of BIM, we maybe expand it to mean it's more than just the model. It's actually about building information management and managing all that information related to the building, or to some respects, actually just better information management. So either way, we've now got a term that perhaps has got so broad it can cause confusion. And now I'm going to introduce a new term, digital engineering. So digital engineering, what does this mean, and maybe how does it kind of play in parts of the digital revolution, those items I explained, and yeah, where does it fit essentially? So the best means for me to try and explain this to anybody is to begin with the built environment. So that is everything that we see around us. And if we consider a singular project, so I'm going to pick one and you will see it form through my slides here, we can consider the built environment to be made up of a set of steps. So we begin with any built environment or any project, we begin with the groundworks. Following that, we require therefore materials to begin the building on which those groundworks were set up for. Starting, of course, with the foundations. It is the basis for our building. We need good foundations for a building of any size or importance, but they have to be in place at the start, and they have to be done well and done correctly. We then, in skyscraper sense, we have a structural core, so it is against which everything else is focused. It is the fundamental for that building, and it is absolutely critical for the integrity of that whole built environment. Off of the back of that structural core, we begin to add some primary elements, so some key cross beams perhaps, and we advance that into being, external walls, internal walls, and eventually we move towards a completed project. So obviously the Burj Al Arab there. But those are the elements we can consider to make up the built environment. Now, one of the biggest challenges within the digital environment is to try and explain, okay, what do we actually do to make up the digital environment and the whole concept of BIM and digital engineering. So we start off with standards. So whether it be BS 1192, PAS 1192, the ISO 19650 that's coming, or something you have internal as a standard, it is the main starting point or the key starting point for getting things right. You need to have something on which you're going to base your way of working. From there, we move through task teams. So who is actually going to be putting together this digital environment? Is it a group of consultants within one business? Is it a consultants across multiple businesses? Do you have a client involved? So on and so forth. So you've got task teams across the digital environment there to enable us to build that. We then have an execution plan. So based on our standards from our teams, we have a plan of how we are going to execute this environment and deliver an outcome at the end of it. From our execution plan, we need to think about the information we're actually delivering as well. So planning out the delivery of that information to ensure that is either meeting our deadlines or meeting our handovers, meeting our deliverable targets. From the information delivery plan, we then need to deliver that information somewhere. So the common data environment, or the CDE, as many people will know it as, is obviously a center point as well. Within that CDE, the centerpiece, really, if we're focusing on BIM level 2, is the primary model. So it should be against which everything else is based. So we have a primary model, and as I say, that is the key point on which everything else is related. Now, I've obviously got an image of a more advanced model there, and in addition to the primary model, we have secondary model information. Now, against secondary model information, there is a whole host of things that fall under there. So whether it be AR, VR, whether it be smart contracts, live data, there's a huge amount of information that falls under that secondary model information. And then finally, we have an asset model as well. The idea that we don't just want a project that's complete. Sorry, I believe my audio connection went there. I'm just confirming that as reconnected. Apologies. Can you still hear me okay? Okay, so sorry about that. So there's a big connection that can be actually made between these. If we think of it, we need to start with groundworks when we are building the built environment. In the same sense, we need standards to form our digital environment. The materials, that's what forms our built environment, and it's the task teams that builds the digital environment. And this is kind of how it develops. Execution plan, it's absolutely critical. Get the execution plan wrong and your digital environment is going to be incredibly unstable, in the same way your foundations would be. And you can kind of develop that up through the whole stages here, everything from the primary models being your external walls down to the asset model needs to exist in the same way your project is completed and then utilized. So in reality, we use engineering as a requirement to deliver that built environment. and it's digital engineering that is required to deliver that digital environment. And it is really, really key to understand the importance of that as part of the digital revolution. So making digital engineering mainstream. So I've divided this presentation into 3 kind of elements. So we're going to start off with the main challenges within the industry, and then look at some improvements that can be made across any company, and then some disruptors. So either maybe some ideas or thinking that we want to involve within our business, or the companies we need to be kind of looking at and going, okay, these are real threats to what we are going to be doing, and we need to be aware of the actions they're taking. But starting with challenges, admittedly, I've only been working, in the industry, seeing as I came out of university kind of 4 years ago, but this phrase is one I come across very regularly. We've been doing it like this for 20 years. Why do we need to change what we're doing? It's a real bugbear of mine as someone who is a huge believer in technology, and it's just convenient that there was a report by McKinsey and Company last year that is clear evidence of why we need to change. So this is a graph showing the productivity performance per person within different industries or for the total economy. So we can see the growth there of the total economy at 2.7% a year, and we can see manufacturing and industry that has done rather well through the kind of digital revolution for that industry, and yet construction really lags hugely behind, 1% per person per year. In fact, even in developed countries, for example, such as the US, the actual productivity over the last 20 years has decreased, which is quite an incredible thing when you think about the fact that we now have all these BIM models, we have Revit, we have smartphones, computers in our hands, we are able to have paperless environments, and yet we have an industry that in a developed or one of the largest developed countries in the world is actually decreasing in terms of its performance from productivity. So why does that happen? Well, let me just throw up a few images here. For those in the UK, you may recognize these as winners for the infamous Carbuncle Award. And essentially, if we do design poorly, then there's evidence of it, and we have an award for that. Okay, it might be rather satirical, but the point still stands. It's quite clear if design is done wrong or there's a failure in communication. With digital engineering, if it's done badly, do we necessarily see it? And I'm of the believer it's not always the case that we see digital engineering that's done badly. We might see it in terms of a cost, but if we're not doing it at the moment, then it maybe is just the cost of the previous project anyhow. So it's really kind of a key point that we don't identify that. And again, this is another very quite surprising chart pulled out of the McKinsey report about the investment within the construction industry into technology, and the fact we are the lowest significant size industry in terms of investment across the whole economy, even significantly below agriculture there. So again, that's quite surprising how little investment there is in technology, and there is definitely a trend between increased productivity and that technology. Now, the idea, which is something I come across quite commonly, which is, oh, it's not our issue to solve this. You know, it's for the leading companies or another organisation to make these changes. So here's just a few kind of examples of cases where actually you need to think that at any part of the supply chain within the industry, whether you're the client who's requesting that project and you're paying for changes or cost adjustments, which is 80% of overruns. That's 80% of the time you're getting into your building late due to changes which could have been captured within a digital engineering process. If you're a tier one, you're paying huge amounts of the cost of a project for labor that you're not improving the productivity of, even over the last 20 years. So surely there should be an incentive there to address that. And as tier two, which make up a huge amount of the industry and are really, really very, very key, you have the tough job of, for the most part, going into projects at the latter stages when things are even more complex and trying to put in specialist services within restricted environments, and as a result can end up out of pocket for it. So the idea that, oh, it affects other people and therefore it's not important to me, I would point anybody in the direction of that slide there. And the value of loss in productivity should not be underestimated. So if we were to catch up with the total economy over the last 20 years in terms of the performance and productivity of our whole industry, it would be equivalent to adding $1.6 trillion to the global economy and would meet half of our needs in terms of infrastructure. Now, you think of projects like HS2 that could simply have been paid for by increasing our productivity over the last 20 years, and it means we're not out of pocket. It could improve housing shortages, which occur in so many kind of countries across the world. As somebody who lives in London, I'm a key kind of obviously believer in that. So 2% GDP growth, these are some kind of really significant figures simply by improving the way we do things. So that leads me on to some improvements. And I'm going to start off with a slide that is taken from a completely different industry, be it the sporting world. There's a chap there called Sir Dave Brailsford that introduced this concept of aggregation of marginal gains. So one of the biggest challenges I come up against when I'm trying to advise companies or maybe go into organizations and explain the benefits of such technology is the idea that they need to make a big change in what they're doing to get any results. And my argument to them is that, no, you don't need to make a big change. What you need to do is make lots of little small changes to what you are doing, and you will end up with a huge improvement as a result of that. And it is why, okay, asthma aside, perhaps, Team Sky won 4 out of 5 Tour de France's. They made lots of small changes, and the same should be applied to our industry. And the kind of concept, oh, you know, we've been doing it this way. It's as I will show at the end. We need to change, basically, and a kind of a little breakdown there of just a few little changes that we could make in different areas. You know, improving the way we collaborate, improving how we execute on site, maybe incorporating more technology. Can end up with huge cost savings, 30% there, cost improvements on our projects by making lots of small changes, opposed to one huge leap, maybe to doing BIM level 2, even though you have no necessary understanding of how that works. So let's kind of move on to that. It leads me nice on to focusing on BIM in a little bit more detail. So if we break down what I've termed the construction ages, we have the idea of 2D drafting, which has developed into BIM. So 2D drafting kind of covering level 0 and level 1. We now have obviously BIM level 2. It's kind of the hot word, if you like, within the industry now, which is focusing on models opposed to the previous age of drawings. And over time, we will see when this really comes into play, we move towards a level 3 idea as well. So the idea that we are connected, we have a system, a whole system in place for the whole economy. So moving through these, the way I'm going to best describe this is to use this, which was explained to me by one of our clients. The idea of a BIM escalator. Whether we like it or not, the industry, the construction or AEC industry, I should say, is on an escalator at the moment. We are moving from level 0, or maybe level 1, me and Casey were disputing this earlier, but we are moving from where we are now to level 2. There is no doubt about that. We have clients demanding it. We have other consultants who are doing it. We have disruptors who are leading the way and at the top of that escalator. So whether we like it or not, as an industry, we are on this escalator. And the choice now occurs of what do we do? So your first option is just to stand still. And that's fine. You know, if you stand still, you will move forwards. The industry will improve. There will be more standards in place. There will be improved understanding amongst your peers of how to do things. And over time, you will move forwards and you will get up to level 2. That's why, we're focused now on it being termed business as usual. We will progress there. Unfortunately, what we see quite a few companies that we've come across either through Asite or through events that kind of I speak at, is to see that quite a few companies actually say, no, we're going to carry on doing it the way we've done for the last however many years. And the problem with that being, if you visualize this as the escalator, is that you are now going against the flow. You are trying to do things like you've done previously, but you can no longer see where you're going. You've no longer got control over your future. You've no longer got control over how you plan to improve what you're doing. You're going backwards up the escalator with really no option but to turn around. So that leads us to the other companies that are actually saying, okay, we're on this escalator now. This gives us an opportunity to move ahead of the rest. Admittedly, I couldn't get the man to walk up the escalator, but this is what I'm explaining here, is to say this is an opportunity for us now as a business, whether it be a small business or a large business. We've got a chance while others stand on the escalator and move up, or try and walk back down, to walk up this escalator, embrace this change and these standards that have been in place, and really use it to our advantage. So my question to any business in this industry is, which one of those three people do you want to be? So another kind of common thing I've come across from working on site and just from working in a few different environments is the idea we spend an awful lot of time looking backwards. So just throwing up a few kind of things I kind of caught over the last week or previously at different client sites. When something goes wrong, who's to blame for that? Why did that go wrong? Whose fault was that? And we look to blame people. We are big on the kind of the blame culture, and we spend a huge amount of time looking at the mistake that has been made, or looking back at why we got in the situation we're in. And again, about this kind of small changes, if we just change our concept a little bit and start saying, well, instead of looking back 80% of the time, let's learn our lessons. That's the 20% of the time we're going to look backwards. But let's start thinking, how do we stop that happening again? How do we actually improve what we're doing? How do we actually improve the training of our team to ensure that doesn't happen again? And I'm a big believer in saying that a mistake isn't a mistake unless it happens twice. And the idea that if we look forwards, if we solve the problems we have in hand rather than trying to blame people, then we will make big step forwards. This kind of concept I took from the aviation industry, who use something called black box thinking, where they essentially look to improve on mistakes they've made, and they will continually improve until the point that they are today. It's now the safest form of travel. So why don't we apply this concept to the industry that we work in? So I'll just quickly jump through this one, but yeah, the idea that if we are going to embrace this, we need to have a bit of an understanding of the different ways in which we're going to work. So spending more time at the start of projects, focusing on getting set up correctly and doing things correctly. It is going to be different, but we need to kind of get used to that. I also wanted to talk about something called project time locks. So again, we live in an industry where we have projects that run for significant numbers of years. Even kind of the smallest projects we work on, are maybe a year in length, and the longest, we're looking at HS2 that might be kind of 10, 15 years, if not longer, from the first concept to actual completion. And the result can be with these projects is you are locked into a technology lock, if you like. When you start that project, you select a specific version, let's say, of Revit or Graphisoft or whatever it might be. You select a specific CDE and a specific naming convention, a specific business processes. And for the duration of that project, you are largely locked into how you use that technology. There might be some movement, but you're fairly limited. When that project comes to an end, you then have a period between project 1 and project 2 where you have time to learn the technologies that have existed or developed during the duration of that project 1, and to try and incorporate them into the ways you work with project 2. Now, this is going on the principle that you have a team moving from project 1 to project 2 without a centralized team. So you are moving kind of progressively from one project to the next. Now, between those two projects, you naturally have a limit on how much you are able to change what you are doing. It's something I've just termed here the learning curve limit. You physically cannot learn so many new technologies in a certain period of time. So you have a limit to how much technology you are able to use on the next project. For example, you might move up 1 or 2 versions of the software you were using on project 1. And that kind of results and continues through the life cycle of a business, to be honest, not just obviously the project, it's the whole process of that business. And you end up with a result that you have a maximum kind of use of technology for your business. The problem being that technology is inherently linked to productivity and improved performance. And if you are using less, you are likely to be less efficient than some of your competitors who have this approach, the centralized digital team. So Casey there has title Head of Digital. It's really key that this is emphasised, the importance of such a role. The idea that actually, if we take away those learning limits and instead say we're going to have one team, who, however big or small, it might be one person in a small organisation, it might be a group of 10, 20, if not more, in a really large global organisation. And what we're going to say is that that team is going to continually learn. Throughout the existence of those projects, they are going to work as a centralised team, and they are going to incorporate and learn new technologies and be able to advise companies on within their own business, of how to improve and how to use that technology effectively. And what you end up with is that these projects, specifically 2 and 3, start with a much greater use of technology. And as a result, we would expect them to have an improved performance output. So a centralized digital team, however big or small, should not be underestimated. Now, the importance of digital engineering, this is a really good kind of anecdote I was told at Digital Construction Week by Andrew Wolfstein, who was the CEO of Crossrail, regarding 2 specific stations on Crossrail. Now, for purpose only of logistics and not for the teams that were designing them, these stations were different in how they were constructed, even though they had many of the same kind of elements. They were of similar size, similar complexity, similar number of elements. Now, Tottenham Court Road could not be constructed off-site, it could not be constructed off-site because of the logistical challenges, whereas Liverpool Street could be. And as a result, you will see there that Tottenham Court Road had 57 people working on site, taking a total of 67,000 hours for the same element as Liverpool Street, which had an off-site kind of production method. So 27 people working in a specialised factory, produced mostly precast, that was then assembled on site. Now, the difference between the total time there used is quite phenomenal. And please don't underestimate, Tottenham Court Road was done in this way because there was no other choice. It's a highly kind of complex and restricted area in which the project was placed. But what should be emphasised here is, if we had 2 cases where we had 2 Liverpool Streets, or Tottenham Court Road was accessible, and we still chose to do it the way that it was delivered, then we are doing it very inefficiently, almost a third of the time on Liverpool Street compared to Tottenham Court Road. So it was a really very good anecdote, and it's something to bear in mind of the importance of doing digital engineering, and also, I mean, probably a real thing for off-site manufacture of a project there. So that's kind of covers the improvements kind of side of things. So how can you start to make small steps towards improving what you do as a business and improving your performance? Now, I wanted to kind of wrap up with some disruptive ideas. So I'm a big believer in looking outside of the industry we work in to kind of improve significantly our approach. It's about looking in a completely different way. It's about looking in a way that your competitors are not. So I'm going to attempt here to tie these companies and some of their technologies to the industry in which we work, even though none of them, barring Cyborg Labs, essentially work in the same kind of area. So let's begin with Uber. One of the, I think in 2017, the fastest growing technology company. That might have been 2016. Why? Incredibly simple. You know where you're going. You know where your car is. You know if you're stuck in traffic, what time you're going to arrive. Now, let's take that principle of you traveling from A to B, and let's apply that to your person on site, your site manager or your logistical manager, who's trying to understand the deliveries that they have got coming. So I worked in a role kind of managing the concrete deliveries for a site in London, and one of the most complex tasks was trying to understand what time all the wagons were due. We had very strict kind of crane lifts, and we had a very tight schedule in terms of when we could get them onto site. So why don't we tie the principle that Uber used to explain how they're going to transport you from A to B and apply it to logistics of a construction site and say, okay, well, we know this wagon is coming at this time, or this steel delivery is coming at this time slot we have available for them. Airbnb, the largest hoteler in the world that doesn't own any properties. Why don't we actually look at different revenue models for how we produce projects? It's something like 80% of the assets that will exist in 2040 already exist now. So why don't we improve what we're offering our clients, look at how we can service those buildings we are built, look at smart sensors, which ties into the next one example I'm going to explain as well, and look to both improve our offering to the clients we are delivering projects for, but also improve our revenue streams as well. This kind of ties a little bit with Nest, so the idea of smart controls within homes or within buildings. Let's advise or offer our clients a better solution in terms of the buildings we are providing for them, by means of having smart data within them, and we use that smart data effectively, whether it be to better analyze or better assess the life cycle cost of a building, or whether it simply be to turn the lights off when everyone leaves the office in the evening. Now, Citymapper is a hugely interesting organization. It's probably my favorite on the list here. They're a company that simply use data very, very well, and all they do is track, essentially, or help you by going from A to B across now many cities across the globe. Now, what they did in London was particularly interesting because of the data that they captured on transport, or transport black spots more specifically. They were able to identify that between place X, I think it started in Angel and down to Waterloo, there was a black spot in the transport network. Where they could introduce a new service, which they consequently did, to generate revenue for them as a business, to improve the whole transport infrastructure for that city. Okay, a brilliant concept. How do we apply it to construction? Well, what Citymapper do really well is capture data passively. They don't have to actively capture the data. They have people capturing the data for them. So let's think on a construction site where our real high costs are and how we could capture that data passively. So cranes, tower cranes on a site. Tower cranes, one of the most expensive, if not the most expensive bit of kit there. Do we track their lifts? Okay, we may have somebody, and I'm not speaking for the whole industry here. Maybe there are some organizations that do this, but we may have somebody writing down, okay, they did this lift, X, Y, Z, this was the order they do. But why don't we actually track how long it takes to do lifts? What lifts are more costly than others? How the lift should be planned in a certain day? Passively capturing the data to improve the way we do things. It then starts to feed in Casey mentioned it previously, the idea that if we have more data, we can start to use algorithms and machine learning to improve the way we do things. So actually that crane now knows its lift sequence at the start of the day, rather than saying, okay, look, you need to do this lift now. You can kind of say, well, no, because that's not efficient in the process of what we're trying to do. Amazon Alexa. Not such a major one in here, but just the idea that now you can not only order with your voice, but you can also have Amazon predict when you will need to order things. Again, quite a brilliant concept. And I mean, related to construction, I would love it if in the FM environment, a kind of, let's say, a new light bulb or set of light bulbs arrived to site without you even knowing that the light had gone out in X room, because it was all connected up as one smart system. So the idea that now we can do this within the retail industry, again, why don't we apply some more of this thinking to the construction industry? And the last one is and I'm going to kind of finish on this one, Sidewalk Labs. The last one is probably the company that the organizations maybe haven't heard about but should be concerned about within our industry. Why? Well, a lot of kind of market or innovators or disruptors tend to go bust if they're too far ahead of their technology. Unfortunately, maybe for us, or fortunately if you're viewing from a different side, Sidewalk Labs aren't really going to go bust, as they are now owned by Alphabet, the largest or second largest organization in the world. And what are Sidewalk Labs doing? So they have won a contract in Toronto to develop an area of hundreds of acres, I can't remember the specific number, into a smart city. So they are building essentially a smart city from scratch. Now, why is this so disruptive? Well, in the UK, we consider ourselves to be fairly advanced in the idea we have mandated level 2, and we are starting to think about level 3. But realistically, the transitional approach to going from where most companies are, probably level 1, between level 1 and level 2 now, towards level 3 is going to take a significant number of years, probably decades, dare I say it, before we really have effective smart cities in play. And what are Sidewalk Labs doing? They are building a smart city from scratch now, and they are going to use it using a completely different approach. Now, many of you may be wishing for them to fail and say, oh, well, it's a disruptor, they're doing everything differently, it's never going to work. But you look at now Tesla, you know, another kind of disruptor, or SpaceX yesterday, putting a rocket or a car in space using completely new technology. So it's certainly one to watch and something to think about. But yeah, thank you for your time, and everyone that joined the webinar. There's some time for questions now, which we will take. But as I say, I want to emphasize the idea of just making those small improvements to begin with. The disruptors, this just there for a bit of I don't know, thought-provoking at the end. But yeah, if you've got any questions or interested at all, just follow me on Twitter, or I will take some now. I think Tracy's there with some, so yeah.
Hi Rob, thanks for that. We've got one question come in. So someone's asking, how would they get the ball rolling in their organization? They've only got a document management, which is a system which is server-based running. How would they migrate to cloud and start to connect the dots, per se, as you mentioned in your presentation?
Right. So yeah, so firstly, you've got to kind of identify what your business processes are and how you can start to improve them. So, you know, obviously as an organization that rolls out CDs for companies, the first thing I will say to any organization is, before I come in here and say, okay, let's put a cloud-based system in place like Asite, how is it actually going to work? So how is it going to work for your business? So you need to understand how you're going to improve your business processes by moving from server to cloud. So what solutions is it going to solve for you, and how is it actually going to work? Once you've identified those business processes, then, to be honest, beyond saying, you know, give us a call directly, I think you need to look at what systems are best in place to meet your needs, and start moving forwards. I mean, the investment, I did pick up on it. I'm not doing that just because, you know, we're selling technology at the end of the day. The construction industry is chronically underinvested in technology, and it will improve you. You will get the revenue back through improved performance by having such a system in place. So yeah, plan out your business processes and then think what systems are going to be in place to improve what you're doing.
Right, that's all the questions we've got today. Just some closing thoughts. I suppose some good advice is to be radical. Reinvention for the digital age isn't about making small incremental improvements to existing processes. It's about boldly creating new ones. The new model is all about breaking down silos and embracing ecosystems. Look at how you can disrupt yourself. Be open and collaborative. We don't believe the best way to innovate is through small, isolated R&D projects. It's more about open, collaborative investigation and developing reusable components of innovation that many members of an ecosystem can adopt and adapt to. Make everyone responsible. Digital transformation needs to be initiated and led by senior management, but embraced by everyone. Most of the leaders in established organizations are of an older generation and don't reflect the demographic of our future clients. Other people who are better at challenging the status quo, experimenting, failing fast, and moving quickly need to be involved. Let's think of technology as an enabler. Perhaps we shouldn't believe that transformation should necessarily be led by the IT department, but by the actual lines of business, as like with some of our clients, such as RHDHV that Rob's involved with. We'll leave you with those thoughts, and any questions we have not had time to answer today will be responded to by email to our guests. Just a reminder to keep your eyes peeled for the next big event on our horizon. It's the New Dawn, and we're going to be doing that release on the 17th of March. So we've got some Twitter and some LinkedIn and some Facebook feed about that that's coming up, so keep your eyes peeled for that. Thanks again for your time and interest, everyone. And remember, any queries, please email marketing@asite.com. We look forward to your comments and questions. Thanks for joining. Bye.